Hello and welcome everyone. My name is Mona Yadav and in this video we will study one more numerical related to viscosity based on lubrication. So now we are aware that there are many conditions in which we can study the numericals related to viscosity, and for current video we will be studying the numerical related to lubrication. So let's see the question. So the question is given as calculate the dynamic viscosity of an oil which is used for lubrication between a square plate of size 0.8 meter by 0.8 meter and an inclined plane with an angle of inclination 30 degree as shown in figure. The weight of the square plate is 300 Newton and it slides down the inclined plane with uniform velocity 0.3 meter per second. The thickness of the oil film is 1.5 mm. So let's try to understand this with the help of diagram. So in this diagram we can see that this is the plane which is inclined to an angle of 30 degree. That's why it is called as inclined plane. So the question is given as calculate the dynamic viscosity of an oil. So we have to calculate dynamic viscosity in this question, that is mu. So we need to calculate the value of mu, which is used for lubrication between a square plate of size 0.8 meter by 0.8 meter. So the size of square plate is given, that is the area of plate is given as 0.8 meter by 0.8 meter equal to 0.64 meter square, and an inclined plane. So we have to calculate the dynamic viscosity of an oil which is used for lubrication between the square plate and the inclined plane. So this is the inclined plane. Why it is called as inclined plane? Because this plane is inclined at an angle of 30 degree and there is a square plate above it and oil is present between this inclined plane and the square plate. So angle of plane is theta equal to 30 degree and an inclined plane with angle of inclination 30 degree as shown in figure. So angle of plane is theta equal to 30 degree. Weight of the plate. So the weight of the square plate is 300 Newton and it slides down the inclined plane with uniform velocity 0.3 meter per second. So velocity of the plate, the velocity with which the plate is moving, it is given as u equal to 0.3 meter per second. So this square plate is having a velocity of 0.3 meter per second and it is having a weight of 300 Newton. The thickness of the oil film is 1.5 mm. So thickness of oil film is given as T equal to 1.5 mm in the diagram. So that is nothing but the distance between the inclined plane and square plate, that is dy equal to 1.5 mm equal to 1.5 into 10 raised to minus 3 meters. So now we know that the viscosity of the fluid between the plate and inclined plane is mu. So we have considered that the dynamic viscosity is represented as mu. So now in order to calculate mu, we need to have this relation of Newton's law of viscosity. So in order to calculate the value of mu, that is dynamic viscosity, we need to have the value of shear stress, that is tau. But how we can have the value of shear stress? So there is one more formula for calculation of shear stress, and that is tau equal to shear force upon area. So now for calculation of shear stress, we need to have the value of shear force. So area of plate is given, but how we can get the value of shear force? So for that we have to understand what shear force is and what is its location. So shear force is the force which is along the direction of the plate or which is along the direction parallel to the square plate. So basically this arrow which is representing the movement of the square plate with a velocity u equal to 0.3 meter per second, in the same direction we will be having shear force. Now we can see that we have only one force represented in the form of weight, that is W equals to 300 newtons. So 300 newtons is the value of the force which is being exerted on this surface because of the weight of this square plate. So now let us try to simplify this diagram. Component of weight W along the plane. So we are interested in the component of this weight W, but it should be along this square plate, along the direction of movement of this square plate. So now if this angle is 30 degree, the angle between the horizontal and this plane, inclined plane, is 30 degree. So this angle, the angle between the square plate and vertical, becomes 60 degree. And if we are interested in this particular component of force along the movement of square plate, so let's try to make a right angle triangle. So if we are making a right angle triangle between the component of weight W, which is moving downwards or which is having downward direction, W is equal to 300 Newton. So we have these two components. Now this component is the adjacent component and another component is the perpendicular component. Now this component is the adjacent component, whereas another component which is in front or which is perpendicular to this 60 degree angle, that is the perpendicular component of the force that is being exerted because of the weight of the plate W. So as we are interested in this component along the movement of the square plate, so the value of this particular component of the force becomes W cos 60 because it is adjacent component. So the value of this force is W cos 60. So W cos 60 equal to 300 cos 60. By putting the value of W as 300, we get the answer as 150 newtons. Thus, the shear force F on the bottom surface of the plate becomes 150 Newton. Just now we have calculated this adjacent component of force whose value is 150 Newton. That's why the shear force on the bottom surface of the plate is 150 Newton. And shear stress, the formula for shear stress we have seen, it is tau equal to shear force upon area. So area we know it is 0.64 meter square. Force just now we have calculated as 150 Newton. So by putting the value as 150 Newton divided by 0.64 Newton per meter square, we get the value of tau as 150 divided by 0.64 Newton per meter square. Now by using the Newton's law of viscosity, we have the equation as tau equal to mu into du by dy. So now we have to calculate the value of mu. For that we have the value of tau. But what about du and dy? So where du is change of velocity, we are aware about du now, that du is the change of velocity. Now change of velocity, this particular plane is not able to move. So the velocity will be 0, but this square plate is able to move. So its velocity is 0.3 meter per second. So u minus 0 equal to u equal to 0.3 meter per second. Also dy. So dy is equals to thickness of the oil film, or the t equal to 1.5 into 10 raised to minus 3 meter. Actually this is the distance between the inclined plane and square plate that is given as the thickness of oil. So t is equals to 1.5 mm, that is 1.5 into 10 raised to minus 3 meters. Now by Newton's law of viscosity, we have tau equal to mu into du by dy. We have the value of du as 0.3 meter per second. We have the value of dy as 1.5 into 10 raised to minus 3 meter. So by putting all the values which we have got yet, the value of tau as 150 divided by 0.64, the value of du, the value of dy, and after simplifying this equation, we get the value of mu as 1.17 Newton second per meter square. So now if we want to convert this value available in Newton second per meter square in poise, then we have to multiply it by 10. So 1.17 into 10 equals to 11.7 poise. So this is the final answer for dynamic viscosity. We get as 11.7 poise. So thank you.